That's different.
I just plugged in 60 over pi r squared.
Yeah, that's something else.
Yeah.
Yeah, that's why I used it.
Yeah.
What did you do then?
I used the volume and the surface area.
Yeah.
You use the area as the surface area? Use the area?
Yeah, first for volume, because it gave us 60 volume,
Yeah.
I used the volume plus area as the line. So that's why I used the area.
Volume, there's a volume equation like on number 3.
Yeah.
So if you use that one, you can solve for h in terms of r.
Oh yeah, that's true.
And then you just plug that in. That's what I got.
All right, guys, I'm going to try to catch up to you. What I teach is in pre-calc. I try to get people, they tell me something, and they ask me something. And I can write both of those equations based on the variables I picked. So it's just some rectangular space. All right, let me draw the general rectangular space, length and width, and then I can write an equation for what they tell me, an equation for what they ask me. And I want area as a function of width alone, so I want to get rid of L, so I want to solve this guy for L. You solve it for the letter you don't want anymore, because then you can replace it. It's very subversive. It's very sneaky. It's very invasion of the body snatcherish. Right? So I can divide by 2, and then subtract W. That's it. Sorry, it's my horrible W impression. And then 20 minus W, just plug it in there. So I get area equals 20 minus W times W. I think most everybody looked at had this one. This should sound very familiar. I mean, that's a classic problem in pre-calc to do. All right, how are we doing there? You're like, yeah, at that point, Jeff, it was okay. All right. Number 2, I helped you out a little bit, but you're going to have to be able to do this on your own. Draw this. It's a square base. All right, so I already got the picture up there, but just a square base, XX, and the height is H. So they tell me, what is it that I'm told? What is that? How does that relate to that?
Surface area.
Surface area. I like it. So we already got the surface area formula. We have 2 of these and 4 of these. And I want the volume as a function of X. Now I know the surface area is 1,000. So this is what they tell me. And then what do they ask me? For the volume. And what's the volume formula in this case? And this is in general. What's the volume of a cylinder? What's the base of a cylinder or circle? So what's the area of a circle? Pi r squared times h times how many times that circle is repeated. Any repeated shape volume is going to have that exact same formula. So I showed you that. Big ass B, remember big ass B? Big ass B is the area of the base. So if I have a square base, I get x squared for the area and then multiply by the height, which is how many times that's repeated. So it's x squared times h. I get hx squares stacked up. Does that make sense? That's how you do any, and I told you that that's called a prism when it's a repeated shape like that, right? Anyway, all right, this is further. So ask me about the volume, so it's x squared h, and they want me to write the volume as a function of x alone. So what do I want to solve this for? For h. And of course I can first cut everything in half, and then I can get h by itself, 500 minus x squared divided by 2x. Is that cool?
Yes, sir.
And then I can just take this and throw it in there. And to be completely honest, if you just killed one of these x's, you're fine. But what you really want to do is split this up. Because what would I probably ask you to do next? These are all just like first steps. This whole sheet is first steps. Where would the calculus come in? What would I ask you to do next? Yeah, find out the rate of change of the volume when the whatever is this, right? That kind of problem from section 3.9. Mm-hmm. So I probably want to put this in the best way for derivatives, which is to pull things apart. So if you stopped here, you're okay, but you should distribute, and so this would be 250x minus 1/2 x cubed And then derivative would be relatively simple after that. I like it. Okay. So that's the volume as a function of x only. Let's see. A cylinder is to be constructed such that the height is always 3 times the diameter. And there's some of our worst enemy, their diameter is not what we want. So if they tell me the height is 3 times the diameter, so how's the height relate to what I really want?
6 times the radius.
Yes, 6 times the radius, because the diameter itself is twice the radius. I like it. So this is what they tell me, and what do they ask me? Well, I gave you that formula, right? They ask me for the volume as a function of height. So I want to take this formula, and what do I want to get rid of? R. So what's R? H over 6. And throw that in there. So I get pi h over 6 squared times h, which will be pi over 36h cubed. Or some iteration thereof. I like it.
Wouldn't it be 6h equals R?
No. The height is 3 times the diameter. So height is...
Yeah, I misread it.
That's right. Cool. How are we doing so far? Decent. All right. And then finally,
Just it was a lot longer.
this number 4 is a little bit different than the others because I'm telling you what I'm normally asking you about here, but it works the same way. What's the volume formula? Well, we just had one for a cylinder, so I tell you that pi r squared h is 60. The volume is 60. And I want the surface area, I give you that formula there, as a function of the radius. So what letter do I want to kill?
H.
H. So how do I kill H? No way. So you solve for the letter you want to, you're going to replace it. So you solve for it so you can replace it. And so the surface area will be 2 pi r squared plus 2 pi r times this mess. So finally, you get 2 pi r squared plus pi's cancel, 1 r cancels, 120 over r. And then I can ask you, how quickly is the surface area changing when the radius is changing by 3 whatevers per second. Right? That's now it's set up for the calculus. All right, maybe.
Can you go back up to real quick?
Yeah. Okay, so in section 3.9, it goes like one step further, but I think we did enough of those similar triangle kind of things. I mean, that shows up in a few different problems where you set up the similar triangles, and that's how you get what they tell you. So it's sort of like hidden what they tell you. You guys kind of with me. We did several problems where they told us, well, it's 10 across and it's 8 up and down, and we're like, no, I want to know for H and W or R for my wherever my water is, and then I can set up the similar triangles, set up the proportion. We did several problems like that. All right, I'm waiting for recognition, but I don't see it. Okay. Okay. So any questions on this little thing here? I mean, these skills are stupid important for being able to do a lot of stuff. In this case, specifically related rates kind of stuff. Okay, so let me give you back your quizzes. They've been adjusted. The average at first was 67, almost 67, with a standard deviation of 24.8 because there were 11 A's. And I want to stop right there, but there were 5 B's, 5 C's, 2 D's, and 19 F's. After the curve, there were 12 A's, 4 B's, 7 C's, 6 D's, and 13 F's. So you can say, man, you didn't curve enough. I curved too much, to be honest.
I remember that part.
Nice.
Oh, yeah. Yeah, you got it.
Christian. Real. Robbie. Brenda.
This is helpful, but this is the formula.
Yeah.
Yeah. I don't know.
Cameron. Kyle Collins. Collins. John. Because this was wrong, threw these off. I just didn't take points on this. Yeah. Austin G. Jesse.
Followed by here, or all these numbers are followed by here, or letters. On the side it was like ABC, but I wrote like they're all followed by here. We did it. It's like what else do you observe? The underlined here by observe. Well, now you know what you got.
Yeah. What'd you get?
Ashlyn.
I got an A.
Troy.
Yeah.
Robinson. Jonathan. Joshua. Solomon. Jose. Toscano. Don. Ryan.